In this, it is given y is equal to sine inverse of x plus sine inverse of square root of 1 minus x square. And x is lying between -1 to 1. Both are not inclusive. Then prove that dy by dx equal to 0. So first of all, let us consider this square root of 1 minus x square as u. So that can be rewritten as 1 minus x square to the power of half, which means our du by dx is half times 1 minus x square to the power of minus half, and then inside we need to differentiate this expression. So if I differentiate 1, it is 0, and if I differentiate minus x square, it is minus 2 times x. This 2 and this 2 gets cancelled. So which means our du by dx is minus x divided by, since it is minus half power, if I bring it to the denominator, it will become positive half, or I can simply write it as 1 minus of x square. So now our y can be written as sine inverse of x plus sine inverse of u, which means our du by dx will be, if I differentiate sine inverse of x, I will have 1 by 1 divided by square root of 1 minus of x square. Similarly, if I differentiate sine inverse of u, I will have 1 by root of 1 minus of u square times du by dx. So now this is u, which means our u square will be 1 minus of x square without square root. So we can rewrite this dy by dx as 1 divided by square root of 1 minus of x square plus 1 divided by square root of 1 minus of 1 minus x square. I am substituting u square for 1 minus of x square times du by dx. Du by dx already we calculated, it is minus x divided by square root of 1 minus of x square. So now dy by dx will be 1 by square root of 1 minus of x square plus 1 divided by, denominator this 1 and 1 gets cancelled, minus of minus x square, it becomes plus x square. So it is root of x square times minus x by square root of 1 minus x square. This is nothing but 1 by square root of 1 minus of x square plus 1 by x times minus x by root of 1 minus of x square. This x and this x gets cancelled. You get simply 1. So we get now 1 by root of 1 minus x square minus 1 by root of 1 minus x square, which is nothing but 0. Hence the proof. In this, it is given y equal to sine inverse of 2x times square root of 1 minus x square. Find dy by dx. So since y is given as sine inverse of something, we can write sine y is equal to 2x times 1 minus of x square, which can be rewritten as 2x times 1 minus x square to the power of half. Now differentiating with respect to x on both sides, we get, if I differentiate sine y, it is cos y, but y is a function of x, so we are going to multiply it with the dy by dx. 2 is a constant, we can keep it outside. So x, we are going to use uv method, means u is x, v is 1 minus x square to the power of half. So u dv by dx means it is half times 1 minus x square to the power of minus half, And then inside we have to go and differentiate, that is 1 minus x square. If I do that, it will be minus 2 times x. So this 2 and this 2 gets cancelled, plus 1 minus x square to the power of half, and if I differentiate x, it is 1. Now this will become cos y dy by dx is equal to 2 times, here we have x into minus x, it is minus x square. And since here it is power minus half, we can bring it to denominator to make it positive half, or square root of 1 minus of x square, plus this one is also square root of 1 minus of x square. That is nothing but 2 times. Let us take LCM as root of 1 minus of x square. So here it will be minus x square, and here it will be 1 minus x square. So this will become now cos y dy by dx is 2 times, we will have 1 minus 2 x square by square root of 1 minus of x square. Now we have this sine y as this. That means cos y will be 1 minus of sine square y, means under root, means here it will be 4x square, and this will be 1 minus of x square. So that is nothing but cos y equal to root of 1 minus of 4x square plus 4x power 4, which can be written as 1 minus of 2 times x square the whole square. I mean, it is like a minus b the whole square. A square is 1, b square is 4x power 4, this one, minus 2ab. Minus 2ab is minus 4x square. So that means this is simply 1 minus of 2x square. That is cos y. So we can write down now dy by dx is equal to 2 times 1 minus of 2x square divided by cos y root of 1 minus of x square. That means dy by dx is equal to 2 times 1 minus of 2x square, and cos y just now we found, here we wrote 1 minus of 2x square, 1 minus 2x square times root of 1 minus x square. This and this gets cancelled. So the result is 2 divided by square root of 1 minus x square. That is our dy by dx. If y is equal to square root of 1 minus cos x by 1 plus cos x, then find dy by dx. First of all, we will rewrite this y as 1 minus of cos x divided by 1 plus cos x. What we will do now is we will extend the square root and multiply numerator and denominator by denominator's conjugate. So which means 1 minus of cos x divided by 1 minus of cos x. If we do that, the denominator becomes like a plus b into a minus b, which is nothing but a square minus b square. This will be 1 minus cos x the whole square. That can be simplified as 1 minus cos x the whole square is nothing but 1 minus of cos x, and denominator 1 minus cos square x is nothing but sine square x, and square root of that is simply sine x. Now we can simply, we already removed the square root, we can simply apply the u by v method. So dy by dx will be u, that is sine x, times dv by dx, du by dx, which is 0 minus of cos x, if I differentiate it is minus sine x, minus 1 minus cos x. Different derivative of sin x is cos x. The whole thing divided by sine square of x. So the numerator is now sin x plus or minus, sorry, plus minus into minus becomes plus. So sine square x it becomes minus 1 into cos x, which is cos x. Minus or minus, it becomes plus. Cos x into cos x, it becomes cos square x divided by sine square x. Now, sine square x plus cos square x is 1. 1 minus of cos x divided by sine square x. So 1 by sine square x is nothing but cosecant square x, and minus we have cos x by sin x. There is one more sin x is there in the denominator. Again, we can write it as sin x. Now, this can be rewritten as cosecant square of x minus cot x into cosecant x. We need to find the differential coefficient of secant of tan inverse of x with respect to x. So let us consider first, let y is equal to secant of tan inverse of x, and let theta equal to tan inverse of x. So here y will become now secant of theta. So dy by d theta will be, if I differentiate secant theta, we will get secant theta tan theta. Here, this indicates that tan theta is equal to x. Now, differentiating with respect to x on both sides, we get, if I differentiate tan theta, it is secant square of theta d theta by dx, because we are differentiating with respect to x. This will be 1. Now, tan theta is x means tan square theta is x square. So that means we can say 1 plus tan square theta is 1 plus x square. So we'll keep that separately. Now we have this. So now we have dy by dx, which is what we are interested in finding it out. That is nothing but dy by d theta divided by dx by d theta. So dy by d theta is secant theta tan theta. Dx by d theta is first of all, let me rewrite this. This is d theta by dx is 1 by secant square of theta. So here dx by d theta will be the inverse of 1 by secant square theta, which is nothing but secant theta. So this secant square of theta, that means dy by dx will be tan theta divided by secant theta. Now tan theta is what? Tan theta is nothing but x. Secant square theta we have, this is secant square theta. Secant square theta is 1 plus x square, which means secant theta will be square root of 1 plus x square. So which means our dy by dx will be x divided by square root of 1 plus x square. That is the result of this particular problem. In this, it is given y is equal to e power x cos x. Find d2y by dx square, means the second derivative we have to find. So given y is equal to e power x cos x, which means dy by dx will be, we will be applying product rule. So e power x, derivative of cos x is minus sin x, plus cos x, derivative of e power x is e power x. Now the second derivative d2y by dx square will be minus of, we will keep e power x, and if I differentiate sin x, it is cos x, plus sin x will retain. If I differentiate e power x, it is e power x. Then the next one, plus will retain cos x. If I differentiate e power x, it is e power x, plus e power x. If I differentiate cos x, it is minus sin x. So what is that? Now d2y by dx squared is minus e power x cos x minus e power x sin x plus e power x cos x minus e power x sin x. So this minus and plus gets cancelled. So we will have now 2 times e power x sin x. That is our second derivative of the given function.